Hey all, so I wanted to add a little bit more to the linear model and show you guys a few more things. So the last thing I had done was a prediction. Remember, if you're going to do the prediction, you have to do a data frame. You have to give it the same name that the other thing had because it's making a prediction of that, right? So here's my prediction here. Now, one of the things that we like with predictions is we like to know confidence intervals. And I think confidence intervals are really important. If you get one thing out of this class, you should recognize that confidence intervals are super important. Um, so what I want to show you here is making the prediction and putting the confidence interval on here. So the confidence interval is so we should be careful here. There's going to be two types of intervals that we can put on. So by the way, my fit for 10 is this first one right here, 4.8. This confidence interval has a lower and an upper. And what this is, guys, is it's the mean, and this is a little tricky here, it's the mean of the predicted values from the 10 that's put in. So when I put 10 in, it predicts 4.847, right? And then what it expects is that the mean of 10 put into the prediction will be between 4.2 and 5.4. So if you had 10 points, it would you expect that the mean of everyone who had 10 points, number of wins, would be between 4.2 and 5.4. Now, there's a second type of interval that you can do, and it's called a prediction. And the prediction interval will be wider. So in the prediction interval, now we're looking for the 95% confidence that the prediction will be between these, not the mean of all the predictions, but the prediction itself. So it gets a little wider because now we're not looking at a measure of the central tendency. We're looking at every individual thing. So we can put a confidence interval, and that will be, the confidence will be about the mean of those predictions, or we can put a prediction. And the prediction will be literally about every one of those predictions. So there's two types of intervals. And again, guys, these are, I should have said this, these are 95% intervals. So we expect 95% of the 95% of the time that the data would fall here, that the prediction would fall between here, and on the confidence that the mean of the prediction will fall there. All right, so that's a little tricky, right? Okay, let's do another thing here. I have done a plot, and I've given the X and the Y, and I've also graphed the AB line of the model. And this gives me my scatter plot. One of the things you should notice here is that I had 30 points, but only a few are represented. It's because some of these points have more on them than the others. So that is a little deceiving that they've been plotted right on top of each other. Like I think this one is very faint, whereas those ones are really dark. So that is a little different. Let's see if I can make that. Well, I don't know how to make that any better. Okay. And you could graph your confidence intervals around this prediction line too. That's something that is interesting. But I showed how to do that in my other document. It just uses the ggplot, and I'm trying to avoid using ggplot. Okay. Let's see. Anything else on my assignment that I should cover? Let's see. Oh, I need correlation, don't I? Let's show you guys how to do the correlation. So I'm giving myself a little snippet here, and I think correlation is CORR. Yep. All right. So data $PTS and data $W. No. Maybe it's just COR. NA. Okay, so if you guys get this NA, how do I do this? NA, pause. So I'm going to tell you guys, NA cannot be the right answer, right? The way we do that is we ask the function to remove the NA values. So I think, hold on. Okay, sorry I keep jumping in and out, guys. I'm trying to keep these short and I'm not doing a good job. Okay, so when I get this NA here, right, that's not correct. You can always compute the correlation, but what happens here is that there are some values that aren't present. So I think this is the function that I wanted, right? So what I did was I Google searched it, and I'm going to open that page here. This is the rdocumentation.org, right? Here's the core, the correlation, the variance, and the covariance matrices. And I see here my core. It says X, Y, default, Y equals null. It says use everything, method equals C, Pearson, Kendall, Spearman. By the way, these ones that already are equal are not required, but you can put them in. I think I just tried a second ago to use this na.rm equals true, and it wouldn't work for me, right? I think I have to use this use thing. So sometimes the students get really frightened by this page because it's kind of a scary page. And I'll be real honest with you, most of the time I don't use a lot of this stuff that's on the functions. I'll just call them in their basic way, but I got NA and that's not right. I know that's not right. So what I look here is I say, well, okay, NA.rm does not work in correlation. It works in variance here. See that? It's right here. So that does work in some of the other functions. Use, though, is here, and it says use everything. Well, if I use everything, that's why I'm not getting a computation there. So what I want to do is I want to say like, okay, I don't need to do all of those, so let me do the let me do only the ones that are complete. So not everything, not all observations. Let's do complete observations. So let's go back to my RStudio and let's say use, and I put it in quotations. Oops, I got multiple sets. And let's ask it to do complete observations. And let's see what that does. Ah, there we go. So it only used the observations that were complete. And this is my correlation. By the way, I think my summary should have probably spit out my correlation somewhere. Was it here? I actually don't see the correlation here in the summary. Okay, so there's my correlation. I do need to do that. Be aware of this, of the NAs. You guys are going to have NAs. If you have any dirty data or incomplete data, right, it'll be there. So there's the correlation. So I did a scatter plot. I did that. Okay. Good. Oh, you know what I need to do? Well, I did that, right? Well, I didn't compute the residual, right? I made a prediction up here. Sorry, guys, I'm just kind of eyeballing it here. I made my prediction here. I made my confidence interval of the prediction. I still needed to compute a residual, right? So there are, in order to do the residual, I have to actually use a value. So let's use a value here. The value I want to use is I want to use 6 points. And we saw that 6 points corresponded to 3 wins. So what I'm curious about is if I can do a residual there. So let's add another thing into here. And ask for 6. So when I ask for 6 wins, I get a fit of 2.8, right? So the residual is actually pretty straightforward here. The residual actually, it looks like I can just do residuals this way. Hey, let's see if I can do residuals this way. Boom. There's all the residuals. Okay, I was working too hard. Let me go through what these are, right? So these are the difference from the prediction, to what the actual value was. In my case here, the one I was trying to do would have been 3 minus 2.80663. and R is going to be mad at me and only print that. No, I printed both of those. And so we see this value, we see it here, and we see it here, and we see it here. So we see that value a couple of times. So that's the residuals. It's pretty straightforward, just a little call there. But this actually gave me all the residuals. And I don't know if, I know I mentioned this before, but the residuals are supposed to be normal. And we looked at those residuals. But what might be nice here is to go ahead and look at the residuals in a histogram. So let's see that too. We know how to do that. And I see the histogram of the residuals. By the way, they do not look very normal, do they? So, you know, that's not a good sign of our model. Okay, I'm going to cut it there.